going to practice solving some multi-step equations, maybe some that look a little bit more complicated, just using all the skills that we've already learned in previous videos and previous assignments. Given an equation that looks like this, we first need to combine any terms that are alike. So these two terms on the one side of the equal sign don't have any variables, and they're just constants, so we can combine those. 24 minus 22 is going to give us 2. Okay, and then all of these terms on the other side of the equal sign have a y included in them, so we can combine all of these terms together. So if we have 30 and then we subtract 3, then we have 27, and then we subtract 17, we have 10. So then we have 10y on this side, and now we can think back to solving our one-step equations. If we have 10 times y, the opposite of multiplication is division, so if I divide by 10, this creates a 1, and then I have to divide by 10 on this side as well. So 2 divided by 10, I can keep it as 2 over 10, I can turn it into 1/5 as well by simplifying it, and 1y is the same thing as y. And once we figure out what y is, we can always plug it back into the original equation to check to make sure that we did all of this combining in math correctly. So we still know that this side of the equation equals 2, and then if we plug in 1/5 for everywhere that we see a y, then we'll get 30 times 1/5 minus 3 times 1/5 minus 17 times 1/5. All right, I'm going to come down here. So we have 2 stays there, and 30 times 1/5. We can think of all of these to be over 1 to help us with our multiplication. So 30 over 1 times 1 over 5 is going to be 30 over 5 minus 3 times 1 is 3 over 5 minus 17 over 5. When I am adding and subtracting fractions, as long as they have a common denominator, I can just subtract the top. So this will give me 2 equals, we know 30 minus 3 minus 17 equals 10. So 10 divided by 5, yes, is 2. So I know that this answer over here is correct because when I plug it back in, it makes my equation true.
All right, let's check out this example here. We got 0.35 times the quantity 200n plus 1 equals 0.25 times the quantity n minus 210.5. Looks kind of crazy, but now that we have some new tools under our belt, we are able to work with this equation. Remember, we talked about the distributive property. I can multiply this here and this here. 0.35 times 200 is 70n. 0.35 times 1 is just 0.35 equals, and then I can also just use the distributive property on this side to rewrite this. 0.25 times n is just 0.25n. And 0.25 times negative 210.5 is negative 52.625. All right, it's very important that when you have a lot of decimals, you want to keep all the decimals because that will make your answer precise. And Derivita will dock you if you don't do that. So now I have an equation with the variable on both sides. Remember, our first step is to try to move our variables together on the same side. I don't want to work with negatives today, so I'm probably going to move my 0.25n over here. So I'm going to minus 0.25n. What do I do this side? I got to do over to this side to make it balanced, and this makes a 0 pair. So now I have 70 minus a quarter n, which is the same as 69.75n plus 0.35 equals negative 52.625. Now we want to tell the story of n. N is being multiplied by 69.75. After that, it is being added 0.35. So if I want to solve for n, remember we just need to go backwards. So to undo 0.35, I'm going to minus 0.35 on both sides. All right, now we have 69.75 equals negative 52.975. So now we have 69.75n equals negative 52.975. Now we go backwards. If I multiply by 69.75, I need to divide to undo that. What do I do here? I gotta do here. And this is a giant 1. I'm left with n equals some crazy decimal here. If I were just to round this and shorten my decimal, Derivita is going to count that as incorrect. I can actually just leave it as a fraction, and that is in its exact form. Just keep the full fraction for accuracy.
If we are given something like this, we know that the area of a triangle is 1/2 base times height. And let's say that we are given that the area is 12 and that the base of this triangle is 3. And we want to figure out, okay, well, what is the height of that triangle then? So we can take what we know and plug it into this formula and then solve for h. So we know the area is 12, so we'll replace a with 12. So 12 equals 1/2. Our base is 3, so we'll replace b with 3, and then we're looking for h. So we'll leave h on the outside. Now we just have to use our solving skills. I'm going to simplify where we can. 1/2 times 3, if we put a 1 under this 3, we can multiply straight across. So this will be 1 times 3 is 3, 2 times 1 is 2, so we can just leave that as 3/2, and then times h is equal to 12. So now let's think about how can we undo this 3/2. Well, we know that if we multiply by the reciprocal, right, then we can undo undo this 3/2. The reciprocal of 3/2 is 2 over 3, so I'm going to multiply this side by 2 over 3, and then I'll have to multiply this side by 2 over 3. So on this side, the 3 over the 3 will turn into a 1, and the 2 over the 2 will turn into a 1. So I'm left with just h on this side, which is exactly what I want. And then over here, 2 times 12 is 24, and 3 times 1 is 3, so 24 divided by 3 is 8. So my height is 8. And if I want to double check that I did all that math right, I can plug in my base and my height into my equation and see if I get 12 as my area. Area is equal to 1/2 our base, which is 3, times our height, which is 8. We simplify this side. 3 times 8 is 24. Multiply that by 1/2, I get 12.
It can be beneficial at times to rearrange your equation to solve for a different variable. So we're going to talk about solving multivariable equations. Oftentimes when we're working with many variables in one equation, we won't have a final number for an answer, but we'll have a new equation expressed in terms of that variable we're solving for. So for example, if I want to rearrange this equation to solve for h, that means I want to get h by itself, and I want h equals, and I'm going to have some equation over here. It might not be a clean number, and that is okay. We want to tell a story of h. So h right now is being multiplied by a couple things. It is being multiplied by b, and it's also being multiplied by 1/2. Because multiplication, the order doesn't matter, I can pick whichever one I want to do first. So I'm going to say it's being multiplied by b first, and it's also being multiplied by 1/2. So let's solve for h. So let's go backwards. So instead of multiplying by 1/2, I'm going to divide by 1/2. Remember, dividing by 1/2 is the same as multiplying by the reciprocal. So I can multiply both sides by 2 over 1, and that will undo a times 1 over 2. Okay, so now if I rewrite it, this is my giant 1, 2, and 2. So I'm left with b times h equals 2a. All right, now I'm at this step. I'm multiplying by b. I want to undo a times b, so I'm going to divide by b. And now that also makes a giant 1. And now I'm left with h equals 2 times a all over b. This is my final answer. I now know that the height of a triangle is equal to 2 times the area divided by the base.
If I'm given an equation that looks something like this, I have lots of variables. I have an x, a y, a z, and then I have a constant of 21, and then I have v. And so on your assignment, you might be asked to solve for a specific variable. Right now, it is already solved for v, and so they might say solve for x. In that case, we want to get x by itself and everything else on the other side of the equal sign. Let's tell the story of what happened to x. X starts by itself, and then because adding, doesn't matter the order you do it, you can do it in whatever order you want. I'm just going to write it in the order that I see it here. X starts by itself, and then it adds y, and then it adds z, and then it adds 21. So we are just going to work backwards from this step. So first, we are going to the opposite of adding 21, which is subtracting 21. Subtract 21 from that side, and this becomes 0. And then we are going to subtract z, and then this becomes 0. And then I have to subtract z from this side as well. And then we will subtract y from both sides. This becomes 0. So now I am just left with this x value. X equals, it's all by itself, which is exactly what I want when I'm solving for x, is equal to v minus 21 minus z minus y. And we can just leave our answer like this because there's not any terms that we can combine.
All right, let's say we have ax plus bc equals d, and it asks us to solve for c. That means I want c all by itself on one side with the equal sign, and then whatever on the other side. Let's tell the story of c. So what is going on with c? C is being multiplied with b, then it's being added with a times x. All right, let's go backwards. To undo a plus a times x, we're going to undo it by subtracting ax on both sides. We got bc equals d minus a times x. All right, next up, it is c is being multiplied with b. To undo multiplication, we're going to divide. I'll divide this side by b. Whatever we do here, I have to do over here. Because I'm dividing this entire side by b, I have to divide this entire side by b. This makes a giant 1 here. I'm left with c equals d minus ax all over b. Another way I could write this as well is c equals d over b minus ax over b. That's another way I could write that because the b is being divided with the d and also with the ax. So I could write it either way. Either of these expressions would be accurate in Derivita.
The last example that we're going to go over today for solving multivariable equations is something that looks like this. Let's say you are given the equation negative 4x plus 12y equals 8, and you were asked to solve for y. So that means we want to get y all by itself, and we want to end up with y equals something in the very end. Let's tell the story of y. If we start with y all by itself, the first thing that happens is it's being multiplied by 12. After y is multiplied by 12, we then have a negative 4x being added onto it. So 2. Now we're going to start at our last step and do the opposite and work our way backwards. So if we are subtracting 4x, we have this negative 4x. We have to add 4x because that's the opposite operation. So a negative 4x plus 4x becomes 0, which is exactly what we want. And then we'll have to add 4x over on this side of the equation as well. So now we're just left with this 12y equals 8 plus 4x. Okay, awesome. We've done that step. Now we're on to this step. If we multiplied y by 12, then we have to divide by 12. And this becomes a 1. Since we divided this whole side by 12, we're going to have to divide this whole entire side by 12, including the 8 and the 4x. So we'll be left with y equals, and like Tiana did in the last example, we can split this up into 2 pieces. We'll have 8 over 12 less 4x over 12. And so we can leave our answer like this if we want to, or we can simplify it. So we'll have y equals, if we divide both pieces of this fraction by 4, this becomes 2 over 3 plus, we divide both pieces of this fraction by 4 as well, we'll get x over 3. Okay, and then we can even go one step further and we can write this as y equals 2/3 plus, instead of x divided by 3, I'm going to write this as 1/3 x. So the benefit of rearranging this original equation and solving for y is now it is in a form where we could graph it if we were asked to graph it, because we have our slope, the number that's connected to the x. A lot of times we see it as y equals 1/3 x plus 2/3. It doesn't matter which order you write it. The slope is the number that's connected to the x, and then this number is our y-intercept. So if we were asked to graph, we could graph it using this